Hello and welcome to a short video on Newton's laws. I'm going to be taking you through Newton's three laws today, and we're going to be applying them to a situation. We're going to need an assistant. Here's Snowbird, our winter owl. So we'll start with the first one, Newton's first law. Newton's first law is often called the law of resultant forces. You might have heard these called net forces before, but the word we're going to use is resultant forces. It's when we consider pairs of forces. So let's consider this pair of forces. We've got 10 newtons acting from the left and 10 newtons of force acting from the right. So overall we have a 0 newton resultant force. So Snowbird is happy where he is. He doesn't start to move, he doesn't accelerate. Let's consider a different situation. This time 15 newtons acting from the left and 10 to the right. So overall there's a resultant force from the left to the right, and that force is equal to the difference between the two forces. So that force has the size 5 newtons. Okay, it's quite simple really, but it's an important thing to understand. If the resultant force is 0, then there is no acceleration. So, tricky one then is if something is moving, like let's take a different situation with Snowbird. There he is, and he's going to go ice skating. If he starts moving off to the left and no forces oppose that, he'll continue moving off to the left with the same speed, i.e. his speed won't change, he won't experience any acceleration. Second law now then. So Newton's second law is expressed by the formula that you'll need to apply in an exam. Force is mass times acceleration. Okay, don't be frightened of the algebra is there to make your life easier. We're going to do a really simple calculation now. We're going to consider Snowbird skating along, and we're going to apply a force of 5 newtons from the left to the right. So the force, let's just write the force in underneath where the F is. Okay, let's write his mass in underneath the M. Okay, and copy out the rest of the equation. The acceleration is the one we want to calculate. So when you rearrange this, you do the inverse, so it becomes 5 divided by 5 equals A. So the acceleration is 1, and the unit of acceleration is meters per second squared. Okay, so that's Newton's second law and how you might apply it. You could also, if you had mass and acceleration, you could work out force. If you had a force and acceleration, you could work out a mass. So similarly to the last one, it can be expressed in words. Oh, the right one. We say the force is proportional to the mass and also proportional to the acceleration. Let's consider now Newton's third law. Okay, Newton's third law is the law of conservation of momentum. Okay, and there's lots about this in a video coming up as well, so have a little look out for that. It's quite tricky to understand the maths of it, but just the basic concept is pretty simple really. Let's imagine that he's stopped, and he's stopped by the edge of the ice rink by the wall. What Snowbird's going to do is he's going to push onto the wall. Okay, now because the wall's fixed there, the wall actually pushes back on Snowbird, and that causes Snowbird to accelerate backwards in this direction. Okay, you'll probably all have experienced it. That's why I choose that example. Get rid of that wall, and 3 for now. Now, another difficult thing to understand about this is, well, even if we consider Snowbird as he is normally standing on Earth, there he is, Well, Earth pulls down on him with the force of gravity. Well, actually, Snowbird also pulls up on Earth with the same force of gravity. So Newton's theory, when expressed in words, is every action has an equal and opposite reaction. With the case of the wall, the action was pushing on the wall, and the reaction was the wall pushing on Snowbird. With the action of gravity, well, Snowbird does a reaction on Earth by pulling up on Earth with gravity. Yeah, it's the same size, but Earth is such a large mass that obviously Earth doesn't move towards Snowbird. Well, I hope that helped. It's just an introduction to motion, really. Tune in for some more videos.